Hello, Professor Sargent here with you again. We're going to take a look at what independent events are and some examples using what we'll know about independent events. So first, the definition. In words, we're just saying that two events are independent if whether E occurs or not has no influence on whether F occurs or not, and vice versa. So if that is not the case, if they are not independent events, then they would be called dependent events. Well, that's all fine and dandy, but how can we know for sure when two events are independent? We need a mathematical way of telling. If we know they are independent, then the probability of both E and F occurring would be equal to the product of the two individual, the product of the two individual probabilities, multiply them together. On the other hand, if you happen to know both this, the probability of both occurring, and each individual probability, each individual event's probability, you multiply them together and you get that it equals the probability of E and F, then you know you have independent events. But when the product P of E times P of F does not equal the probability of E and F, then you don't have independent events. As a little side note, some textbooks refer to E and F both occurring as the intersection of those two events and use this symbol. Whether your textbook uses that or not, depends. All right. And one further fact before we get to the examples, the multiplication rule that we just stated, it's stated for two events, but you could keep this going for however many events that you have. You want E, F, and G to occur. If each pair, E and F, E and G, F and G, if they are independent events, then the probability of E and F and G all occurring would be probability of E times probability of F times probability of G. Okay, so we start off with, according to the US Census, 49.2% of people in the country are male. The percentage of left-handers is estimated to be 13.1%. Are the events in the US and a male and the event in the US and left-handed mutually exclusive? Why or why not? The answer to that is no, they are not, because one can be both male and left-handed. I'm an example of that. So this has not proved anything, but we're trying to get you to recognize that there's a difference between the concept of mutually exclusive events as for about here versus the concept of independent events. We're not talking about the same thing, even if we may wind up using what we know about each. In some cases, they are not the same. Okay, assuming that handedness is independent of gender, compute the probability that someone in the US selected at random is male and is left-handed. Okay, so we've got the word and, we've got the word independent. We're going to be using the multiplication rule. Notice that we have the events and then we have the probability of the events. So I've just copied that down, and let's take a look at the board now. To multiply these, we're going to have to convert those percents to decimals. And so if in fact the probability of male and the probability of being left-handed are independents, then we could do this multiplication, but we need to move the decimal place 2 to the left in each case. So that's what we're going to be multiplying, and I'll bring up the calculator in just a moment. Note that we are asked to round to 4 decimal places. All right, here we go. Multiplying 0.492 by 0.131 and rounding that to 4 places, we've got in the 4th place a 4, which is followed by 5. So that 4 is going to be rounded up to 0.0645. 4 places, that was 0.0645. Now, next we are asked for computing the probability of male or left-handed. Or we need to use what we learned about addition, and then worrying about whether or not we have mutually exclusive events. So, or, remember some textbooks call that the union of 2 events and would flip this symbol over. So one way of expressing this, of finding out this value, let's see if I can find the union symbol here real quick. Make sure, okay, good. Union symbol. Right there. Okay, one way of finding this would be to add the 2 individual probabilities and then subtract the probability of the intersection of both occurring, which we just calculated. Okay, so that would be, here we could either have them all as percentages or all as decimals, and then watch for how they want the answer expressed. So if I leave the originals as percents, I would have to convert the 0.0645 to 6.45%. All right, so $49.2 plus 13.1 minus 6.45. That would give us 55.85%. If, however, they wanted it left as decimals, well, you could convert this back by moving the decimal place to the right, 2 to the left. Or we could have just added 0.492 plus 0.31 plus 0.131 minus 0.0645 and would get the same thing. Now, suppose in fact that the percent of males in the US that are left-handers. In other words, they're in the US, they're male, and they're in the US and they're left-handers is not 6.45% approximately, but 10%, then what that tells us, since these two sides right here are not equal, then it would tell us that those two events are not independent. The assumption in part B would be incorrect if that was the case. And finally, if that really was 10%, then what that would change here, change the 0.0645 or 6.45% to a 10%. And what that would give us would be, let's see, 62.3 minus 10% should be 52.3%. Let me double check that. I'm going to leave those as decimals though. So I'll convert the 10% to 0.10. Yeah. Change this to addition. And subtract 0.10. 0.05, sorry, 0.523, which does equal 52.3%. Now, by the way, before I end this video and go on to one more example, let's take with just this part. You could use a Venn diagram instead. Do you have overlap? We had the 49.2% that are male. And 13.1% that are left-handed. If I take away the 10% that's in the middle from 13.1, then we would have the left-handers that are not male. And then if I take away 49.2% minus 10%, (39.2%) in the US that are male but not left-handed, and or just wants us to lump all these together. So we could add up the following three things and get our 52.3%. That's going to give us 49.2%. Add on the 3.1%, and now we've got 52.3%, or if they want that as a decimal, 0.523. That could have also been used in part C. One nice thing about the Venn diagram is if you're asked about multiple things, you could also find out what percent are not male and not left-handed. So that would be the complement of this. Let's see here, minus 52.3%. Well, if I didn't have that 0.3, then I'd have 48. I'm gonna have to take away 0.3 from that to get 47.7% not male and not left-handed in the US. Okay, back in a moment for another example.